Hi, I'm Mudinda and I'm here to help you understand maths better for free. Now, matriculants, in this video, I'm going to introduce series to you, the second part of our sequences and series topic. Now, a series is exactly like a sequence, except it's the summation of a sequence. That is, adding together all the terms of a sequence. For example, this is a sequence. We've just replaced the semicolons with pluses, right? So it's a series. Now, it's very easy to compute the value of this one. 3 plus 6 plus 9 plus 12 just gives us 30. Okay? But sometimes you might be asked to sum many terms together. You can't really do that manually, and so we're going to learn of two formulas that help us to add many terms together without it being tedious or repetitive. We're going to call those the finite series formulas. We're also going to teach you a funky new way of writing out the sum of a sequence, or in other words, writing out a series. It's called sigma notation, and you'll see it with this new little summation sign. Maths is getting more and more interesting. We're also going to learn a formula to add an infinite number of terms together. How can we find the sum to infinity? Now, let's get started. When it comes to arithmetic series, they have some formulas. The first one is that the sum of the first n terms, you could replace n with 3 if you want to find the sum of the first 3 terms. You could replace n with 100 if you want to find the sum of the first 100 terms. That is always equal to n over 2 into a plus l, where a is your first term and l is the last term. But we're going to be using this formula more often. It says that the sum of the first n terms is equal to n over 2 into 2a plus n minus 1 times d. Let's look at some basic examples. If you were given the following sequence and asked to sum or determine the sum of the first 20 terms, it would be tedious for us to add up those 20 terms manually. But we can use our finite series formulae to determine the sum of the first 20 terms. Firstly, what's the common difference here? We have 17, then 21, then 25, then 29. So clearly, we're adding 4 to each term. So D is 4. Meaning that the sum of the first n terms we know is n over 2 into 2a plus n minus 1 times d. So in our case, S20, the sum of the first 20 terms, is equal to 20 over 2 into 2 times 17 plus 20 minus 1 times d, which is 4. Great. You can go ahead and put all of that in your calculator. 20 over 2 into 2 times 17 plus 19 times 4, and that'll give you 1,100. So the sum of the first 20 terms of this sequence or series is 1,100. Now, the next question says, find the sum of the first 30 terms of an arithmetic series with Tn is equal to 7n minus 5. To help us do this, we could start by finding the first term, which is 7 times 1 minus 5, which gives us 7 minus 5, which is 2. Then the second term, T2, is 7 into 2 minus 5, which is 14 minus 5, which is 9. And then the third term, 7 times 3 minus 5, which is 21 minus 5, which is 16. Now, if you subtract term 3 from term 2, 16 minus 9, you'd get 7. If you subtract 9 from 2, you'd get 7 as well. So the common difference D is 7. Now, there are two ways we could answer this. You could say, well, Sn is equal to n over 2 into 2a plus n minus 1 times d, meaning if we're trying to find the sum of the first 30 terms, that's S30, which is 30 over 2 into 2 times the first term, which is 2, plus 30 minus 1 times the common difference, which is 7. Okay, now that would give you, if you put it in your calculator, that would give you 3,105. Alternatively, you could find term 30, the last term. Term 30 would be 7 times 30 minus 5. And 7 times 30 is 210. 210 minus 5 is 205. So now you have that the first term is 2 and that the last term is 205, and you can find Sn as n over 2 into the first term plus the last term. So S30 is 30 over 2 into 2 plus 205. Now, if you put that in your calculator, 30 over 2 into 2 plus 205, you will again get 3,105. I just wanted to show you that both these formulas work. That's how you find the sum of the first n terms of an arithmetic series. What about this one? Find the sum of the following series: -5, -3, -1, plus yada 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 till 123. Don't get confused by seeing these weird negative numbers here. This is just -5 plus -3 plus -1 up until plus 123. You can simply find this by saying Sn is equal to n over 2 into a plus l, right? And saying, well, we don't know how many terms these are, so we can't really go with that formula yet. How about we find d, which is -3 minus -5, right? -3 plus 5 is 2. If you took -1 and subtracted -3, that would be -1 plus 3, which would also give you 2. So the common difference here is 2. Let's find Tn. Tn is always equal to a plus n minus 1 times d, right? Which means in our case, it's -5 plus n minus 1 times 2. So Tn is -5 plus 2n minus 2. So Tn is 2n minus 7. This is Tn. Using Tn, we can figure out the term number for the last term. Okay, we can say, okay, well, what about when Tn is 123? What is n? Okay, now 123 plus 7 is equal to 2n. So 2n is equal to 130. And if we divide both sides here by 2, we get 130 divided by 2, which is 65. So what do we know now? We know that there are 65 terms. 123 is the 65th term. And so we can now employ Sn is equal to n over 2 into a plus l, because we know that we are finding the sum of the first 65 terms. The first term is -5, while the last term is 123. Now, if you put that in your calculator, 65 over 2 into -5 plus 123, that would give you 3,835. So, what was different between this question and the other ones? Well, here, we weren't told to find, say, the sum of the first 100, the sum of the first 60. We were just asked to find the sum of the series, and then we were shown that it has a last term of 123. We then had to figure out, what is the n? What is the term number? We know that the value of the last term is 123, but what is the term number? I hope that language rings a bell from our very first lesson. Now, let's talk about how to find the sum of a geometric series. Here's the formula. It says Sn is always equal to a into r to the n minus 1 over r minus 1. Remember, a is the first term, while r is the constant ratio. If you wanted to find the sum of the first 30 terms, you'd plug the first term, you'd plug 30 in there, and you'd plug the constant ratio there. Remember, we can find the constant ratio by taking term number 3 and dividing it by term number 2. Should give us the same answer as taking term number 2 and dividing it by term number 1. Find the sum of the first 25 terms of this sequence. 4, -8, 16, 32. Well, first of all, what's r here? Well, you can find r by taking -8 and dividing it by 4. That gives us -2. Now, you don't have to do this, but it would give you the same answer as if you took 16 and divided by -8. If you took term 3 and divided by term 2, that's also -2. Please note that when you have a constant ratio that's negative, your sequence will alternate between negative and positive numbers. It will go from negative to positive, to negative to positive. Because when you multiply a positive number with a negative, you get a negative result. But if you multiply that negative result with a negative number, you get a positive result. And if you multiply that positive result with a negative number, you're going to get and so on and so forth, right? So it's just going to alternate between positive and negatives, okay? That happens, and don't be alarmed by it when you see it. It just means that the constant ratio is a negative number. Find the sum of the first 25 terms. Well, we know that Sn is always equal to a into r to the n minus 1 over r minus 1. This is the formula for the sum of a geometric series. And so the sum of the first 25 terms would be 4 into -2 to the power of 25 minus 1, all divided by -2 minus 1 in our case. You can go ahead and chuck this in your formula, and you should get a big number. And it's 44,739,244. That's the big number you should get. Okay. Here's an interesting one. How many terms of the sequence sum to 4,100? You can give it a try if you have an idea. But how do we tackle a question like this? Well, this question is telling us that there are a certain number of terms here that if you add together will give you 4,100. In other words, instead of asking us find the sum of the first 25 terms where we've been given n as 25, we've now been given Sn as a value. We've been given that the value of Sn is 4,100. The sum of a certain number of terms is 4,100. So we can replace Sn with 4,100. This is very similar to that whole n and tn chat that we started with in the first video. So Sn, we know, is always equal to a into r to the n minus 1 over r minus 1, right? So 4,100 is equal to 4 and -2 to the power of n. We don't know how many terms sum to that 4,100, and then -2 minus 1. So 4,100 is equal to 4 into -2 to the power of n minus 1, all divided by -3. We now have two fractions separated by an equal sign. Let's multiply that 4,100 with a -3. We get -12,300 is equal to 4 into -2 to the power of n minus 1. Well, let's divide both sides here by 4 to get rid of this guy. Well, what is 12,300 divided by 4? That gives us -3,075, being equal to -2 to the n minus 1. I'm going to move that 1 to the other side. This 1 goes to that side. So we get -3,074. Being equal to -2 to the power of n. Then let's just divide both sides by -1 so that we have 3,074 being equal to 2 to the power of n. Now, some of you may be confused as to how to solve this, but if you at this point have learned about logs, you would know that the unknown exponent n is equal to log with a base of 2, and the number on the other side of the equal sign is 3,074. Okay, now on your calculator there's a little button that looks something like this, and you can use it and put 2 in that little space and 3,074 in that big space, and it will literally give you the answer. Okay, and so n looks like 11, 5